Right, so we've looked at tangents and normals to the hyperbola in Cartesian form. So there's a couple of formulas that we have derived. To get the formulas, you can either remember the formulas off by heart, or better yet, learn how to derive them. Okay, so the equation of the tangent. So we've got that. Remember that point that was shown in parametric form. So x equals a sec theta and y equals b tan theta is the parametric form of your hyperbola. Is given by that. Okay, so let's derive it. So x is a sec theta. So we need to do dy d theta. Okay, so we do achieve that by doing dx theta. Alright, so I'm going to rewrite it so I can differentiate. So I don't know how to differentiate a sec theta yet. I do know how to differentiate a cos. Okay, so dx d theta, so we've got the product rule, the quotient rule. Right, so second times the derivative of the first, so remember a is just a constant number, so it's going to be 0. Take away the first, so negative a, times the derivative of cos. So we differentiate sine, we get cos, so when we differentiate cos, we're going to get negative sine. We'll have second squared, morning. Alright, so we've got a sine on top with one cos on the bottom, so sine of cos becomes tan, and then we still have the cos on the bottom, so I'm going to write it as sec theta up on top. Right, so the other part is the parametric is b tan theta. So again, I want to differentiate y with respect to theta. So dy d theta. Right, so I know how to differentiate tan, and that's what? Set squared to b sec squared theta. Right, so we're showing the equation of the tangent is given by that formula there. So, what I need is the dy dx, and I'll achieve that by doing dy over d theta times d theta over d x. Okay, so use the chain rule. So dy d theta is on that side. So b squared, b is sec squared. Now we've got a d theta dx, we've got dx d theta, so we need to flip this. Okay, so times, really we're dividing by times 1 over, but same thing. Right, so a tan theta sec theta. Right, so we've got b sec theta over a tan theta as the gradient of the tangent at any point on your hyperbola in parametric form. Right, substituting point gradient formula. Right, so you're already given the coordinates, it's in parametric form, substitute x1 and y1. So we need formula x sec theta take away y tan theta. Okay, there's x sec theta and y tan theta, so I'm going to put them on the same side and then move this onto the other side. So we've got the x sec theta first, so I want to make that positive. Move that over to the other side. Right, so move the AY on that side, AY tan theta and AB sec theta, and I'll factorise because AB is the common factor. That should be tan squared. So what's sec squared take away tan squared? 1, okay, because 1 plus tan squared is sec squared. Okay, so sec squared take away tan squared is 1. And if I divide everything by AB. Alright, so this is going to be 1 eventually. Because AB divided by AB, and then this is already 1. X sec theta over A take away Y tan theta on B. As required. Right, so the gradient of the tangent is B sec theta over A tan theta. So we now need to do the normal. What would it say? B sec over A tan, so negative A tan over B sec. Right, so I'm looking for A squared and B squared on the same side, and AX and BY also on the other side. Right. Yeah, just span it right out. So my tan squared sec squared, my tan theta sec theta is with my A squared and B squared, so I'm going to group them together. So I'm going to move this one over to the other side and then bring this back to this side. Alright, so observing again, I've got the common factor of tan theta sec theta. I'm factorising A squared and B squared out. Alright, so this one, because I've got the A squared plus B squared on the right hand side, so I'm going to divide everything by tan theta sec squared. Tan theta sec theta. so AX over sec theta plus BY over tan theta is going to be A squared plus B. Right, as required, good. Any questions on the proof? Right, let's try a couple questions. To find the equation of the tangent and normal to the hyperbola of that at the point where theta is 3 pi and 4. Right, so I'm not going to, well, I could. You want to use the formula or you want to have a go at deriving again? Hey? Okay, so the tangent is x sec theta on A, take away y tan theta on B. X sec theta, y tan. Okay, so there's the format for the equation of the tangent. That is the equation of tangent, so we can do more now. We've got some more info. Right, so remember x is A sec theta and y is B tan theta for your parametric form of your hyperbola. So we can substitute A and B in there. And we have more information about theta. Okay, so theta is 3 pi and 4, which is what angle? $135, so it's an angle in the second quadrant. Okay, so thinking, all students take calculus, the angle in seconds, the sine is positive and cos is, sine is positive, so tan and cos are both negative. Okay, so remember sec is reciprocal of cos, so we need to tidy it up with the negative as well. Right, so we have x over, so I've got, just going to write it cos on the bottom just to not get myself further confused. Take away y tan theta on B, one. Alright, so tan of 45, great, works out to be 1. And cos of 45 is 1 over root 2. Alright, so we're going to have x over 5 over root 2, so the root 2 is coming up top. And a negative sign because it's negative in the second quadrant. And then tan of 135, negative 1. So we're going to have plus y on 3. Move on. Tangent and normal. Right, so y over 3 is going to be 1, root 2 over 5x. Take away 1. I just like writing it in y and x plus b form because I can easily read the gradient and that will help me down the track maybe. It's going to be 3 root 2 over 5x. Right, so that's tangent. You're going to need the normal. Okay, so we derive the normal as that. So AX over sec theta. so it can be, this gets derived exactly the same way as I did, but now that you know what the value of theta is, that will change your approach slightly. Right, so we've got A as 5 and B as 3. So 5x cos theta, so I'm just rewriting it in a way that I'm going to feel a bit more comfortable. Then we have 5 squared plus 3 squared to finish the right hand side. 25 plus 9. Okay, the cos of 135 is negative 1 on root 2. So we got negative 5 on root 2x. And tan theta is 1, so plus 3y, so 30, sorry, is negative 1, so this needs to change to a negative. Alright, so 3y is going to be 5 on root 2x. Just going that one, let's go that way, 34. Y is going to equal 5 on 3 root 2x, take away 34 and 3. So? Nope, because you're dividing by 3.
Wouldn't the 5 root 2 be negative?
So?
Wouldn't the 5 root 2 be negative?
Yes it would. Right, let's go back to me saying take as many steps you need. Okay, so obviously I'm taking too much at once. Okay, which makes sense because I'm expecting the tangents to be perpendicular on that because we've got 3 root 2 and 5 and negative 5 and 3 root 2. Right, so that's one thing you can do to check your work from there. Alright, any questions? So really just algebra and calculus. So all it is just adding a few extra steps into what we're learning at the moment. Alright. So we've got the point P and Q. So notice the point, the x value are the same. The y value is the negative and positive equivalent. Alright, so you're thinking about the location of that on your hyperbola, where the foci lie in a horizontal plane. So the normal at P meets the line OQ at R, and then show the locus of R is a concentric hyperbola. Okay, so the concentric circle is a series of circles with the same centre point. Okay, so it's the concentric hyperbola is going to be a series of hyperbolas all with the same centre point, which will be at the origin for that one. Right, so what's the very first thing I need to do? The very first thing. Draw a diagram. Okay, always at least draw a diagram. Alright, to help you with the understanding of the question. Right, so we've got 2 points on the hyperbola. So again, I've observed that the y squared is the negative bit. Okay, so that means the foci lie on the horizontal axis. Okay, so we've got the point P, the 3 sec theta and 2 tan theta and Q, so which is 3 sec theta negative 2 tan theta. Okay, so those 2 points are going to lie in line, in a vertical line with each other. Alright, so I'm just going to pick 2 points, P and Q. Doesn't really matter, but it'll help you with your understanding the question a bit further on. So, the normal at P meets the line OQ. Alright, so let's put in the line OQ. the normal. So the tangent will be somewhere like this, so the normal is going to be the perpendicular, and that's your pointer. Okay, so we now need to show the locus of R is a concentric hyperbola. So in other words, show it's a hyperbola with the centre at the origin. Right, so after drawing that sketch, does this question seem that little bit more, I wouldn't say easier, a little bit more better to comprehend? Okay, well, I'd much rather look at the diagram there than looking at retreating through the question again. Okay, so I'll try and label as much as I can. 3 sec theta, 2 tan theta. Right, a few things we need to do. First thing, we can write the equation of the normal at P. Alright, so we just derived that. So again, A sec theta, B tan theta. Okay, so the equation will become 3x over sec theta, so using the formula that we just derived, plus 2y over tan theta is equal to a squared plus b squared. So 9 plus 4, which is 13. Right, OQ. Alright, so we need that equation of OQ. So we have it going through the origin, so there's no y-intercept constant that we need to have because it goes through 0. Alright, but I can write down the equation of it simply by noting that this is the gradient, form that right angle triangle, using your formula y2 take away y1 over x2 take away x1, where y1, x1 is going to be 0. So, equation of OQ simply going to be negative y equals negative 2 tan theta over 3 sec theta. So the change in rise, which is negative 2 tan theta, and the change in run 3 sec theta, which is your gradient. Okay, so that's your equation of tangent. The equation of the line OQ, which is not a tangent. Okay, because you're not told that it is. Alright, so I'm going to write it, to help me in the long run, I'm going to write it like the first equation, solution number 1. Alright, so I'm going to multiply that's cross multiply. And I'm going to move that 2x tan x onto the left hand side. Divide by 3y over 10. So I'm going to divide everything. So 3y sec theta plus 2x tan theta is 0. I'm going to divide everything by tan theta sec theta to remove them from the top. And just swap to do it. X's before Y's. Two. So, to find the locus of something, what do we need to do? What's the general rule? We have to eliminate the parameters, okay? So we need to eliminate thetas. in this and get something in terms of x's and y's without theta. Okay, so what I'm going to do is I'm eventually going to set it up to a elimination method of simultaneous equation. Okay, so I'm going to take away these equations from each other. But before I do, because if I take them away now, I'm still going to have another equation with both variables. What I'm going to do is make the coefficients on the numerator the same for each of the sec and tan terms, so that when I do a subtraction, it will then allow me to have the process of elimination. Alright, so the first one I'm going to work on is the sec, and you have the equation for that. So I'm going to eliminate the tan theta variable by making sure the numerator is the same. Okay, so the numerator is 2y and 3y. So I'm going to change them both to 6y. So I can do a subtraction and it will eliminate that variable. So equation 1, I'm going to multiply that by 3 to get that 6y. So 9x over sec theta plus 6y over tan theta is equal to 13 threes, which is 39. That's equation 3. And then equation 2, I'm going to double it so that I get the coefficient of coefficient of y as 6. Oh, sorry, yep, here, as 6. Multiply everything by 2, so 4x over sec theta plus 6y over tan theta is 0. Okay, so I've set it up so 6 and 6 is the coefficient of y. So if I do an elimination of that by doing a subtraction, so 3 take away 4, I'll eliminate the tan theta variable. Okay, so 9x over sec theta take away 4x over sec theta. You've got 9 take away 4, 5x over sec theta is equal to 39 take away 0. So sec theta is going to be 5x on 39. Alright, number 5. Right, so from the last one we had y is, sec theta is 5x on 39. So now what we need to do is do the same sort of approach for the x variable. So we're going to eliminate that from 1 and 2. So again, I've got 3x and 2x. If I change them both to 6x by making an appropriate multiplication, I'll then be able to do this, take away that, and then have an equation just with tan theta and a constant number and y. So, in there. So if I double equation 1, that will give me 6x here, and I'll triple equation 2, I will get 6x here. Right, so equation 1, double it again. 6x over sec theta plus 4x over tan and 13 times 2. Got 2, 6. Okay, and then the second my original equation going to triple it so I can get the coefficient in front of x as 6. So 6x over sec theta. And then it was 3y over 10, so it becomes a 9y over 10. And 0 times 3, it's equal to 0. Okay, so the reason I've done that, because I've got the coefficients in front of x the same, so then I can do equation 6, take away equation 7. Okay, so it's going to be more messy if I do a substitution method. If I solve one of them and substitute into the other, I think it will be much more messier. That's why I'm doing the elimination method. Alright, so if I take these two away, it's going to be 0. That from that, sorry, you get 0. So I've got 4 take away 9. So negative 5y over 10 is equal to 26 take away 0. So tan theta is going to be negative 5y on 26 over 8. Right, so I'm observing that I've got the parameters as sec theta here equal to something in terms of x, and tan theta is equal to something in terms of y. Alright, and I'm also thinking I know a formula that has tan and sec in it. Okay, so from this formula, I can then get my equation of the hyperbola. Because they are, of course, the parameters used in the hyperbola. So solve for 1, so sec squared theta, take away tan squared theta. Okay, so number 9, and we need to put equation 5 and 8 into 9. Because I now have an expression for sec squared and tan squared. So 1 is going to be 5x on 39, all squared. Take away negative 5y on 26, all squared. Okay, so you've just eliminated the parameters. So 25x on 39 squared, I'm not going to bother squaring it, you can if you want, you don't have to. X squared, take away 25y squared on 26 squared is 1. And that's the concentric hyperbola because the format is the equation at the centre. And it equals 1. Okay? So, 9 equation, but we got there. Any question? Alright, let's go backwards, something a bit more easier.